Good afternoon. Today I will see the basics of the thermodynamics. Thermodynamics means itself is a flow of heat. It means thermodynamics means study of the energy transformations. In the thermodynamics, some commonly used words are system, surroundings, open system, closed system, isolated system, and state function or state variable, internal energy, first law of thermodynamics. So today we will see these terms and the what is the relations and all. The thermodynamics deals with the energy changes in macroscopic way, not microscopic. That means we do not deal the changes in microscopic atomic level. We deal the changes in macroscopic way. That means changes in volume, changes in temperature or pressure or mass and all. Now, what is system? System is nothing but the aspect or the one which is under consideration. Other than that is surroundings. For more practically easy this thing, for my system now, my mobile, myself are the system, the entire other things are the surroundings. For a lab experiment person, a beaker, a pipette, a pipette or whatever he is considering, he is doing the experiments, that is system, remaining things are surroundings. For a bigger person of the who is observing the stars and all, for him the entire sky is a system and remaining things are the universe. So system is nothing but the what you are considering this thing. Then in thermodynamics, open system means there is an exchange of matter and there is an exchange of heat. That is called open system. In the closed system, the mass transfer and heat transfer both is not there, only heat transfer is there. It is a closed system. Mass transfer is not there. In open system, both are there. In the closed system, only heat transfer is there. In isolated system, no mass transfer, no heat transfer also. That is isolated system. Then in this we add two more terms called isothermal and adiabatic. Isothermal means in the system the temperature is constant. Isothermal. Temperature is totally constant. Adiabatic means temperature may be varying but heat is constant. Adiabatic. That is the adiabatic system. Now, next one is what is thermodynamics actually dealing? It is dealing with the chemical reactions, the changes of energies. Change may be heat energy, or it can be a mechanical, or it can be a electrical, whatever it is. But total energies will be same. And what it doesn't see is how fast a rate of reaction and what are the conditions required for a reaction. But whereas thermodynamics deals with whether a reaction takes place or not. But it doesn't deal with how fast it is, how slow it is, and what are the conditions also. Next comes to adiabatic. Adiabatic means quantity of the heat is constant, temperature will vary. Now next comes to a state function. State variable sometimes people will say, or state function also it will be say. Before going to that, macroscopic, what are the state functions of the macroscopic this thing? Pressure, volume, temperature, mass are normally described. Means to describe a system, what are the minimum things required? They are the state functions or state variables. Very simple. If I want to define a system, I require pressure, volume, temperature and mass. So these are called the state variables or state functions. Very simple, normally, general. That means the system is depending on these variables. Sometimes may not be required all the variables, but maximum is these 4. Now, one more term we are going to introduce, that is called internal energy. That is also a state function. How? Because by specifying the internal energy or by describing the internal energy, we can describe the system. So, internal energy is also a state function. Why? Because when we talk about a chemical reaction, that chemical reaction is involving a change of energy, that is either it is losing energy or gaining energy. Total, whether it is losing or gaining, sometimes it may be losing, sometimes it may be gaining. Total energy is mechanical or electrical or chemical, whatever it is, totally. By describing this chemical internal energy, we can describe this system. So it is also a state of function, and it will change the internal energy will be the changing the by heat giving, the internal energy will change. By doing work, it will change, the internal energy is changing. But it doesn't depends upon how you are doing the work or how you are increasing the energy. Simple example I will tell. I am taking a thermos flask with water. By adding steam, I am increasing the energy, internal energy. This is first case. In another case, by putting a stirrer and doing a churning action, I am also introducing the same change. That means what is the means, it doesn't bother, but it means the initial state of the variables and final state of the variables. What is the initial delta E and what is it final? Root is not this thing. Now here we are going to define the first law of thermodynamics. What is the first law of thermodynamics? First law of thermodynamics is nothing but energy conservation. Meaning is energy cannot be created, neither created nor destroyed. That is a general first simple statement. Slightly elaborating, we can transform the energy from one form to another form, means from mechanical to electrical, electrical to heat, heat to chemical, or whatever the way you want is. Efficiencies may be different, but you can transform the one form to another form. Simple, I will take a boiler. In the boiler, what is happening? Coal, a chemical energy, we are converting it to steam, means heating the water. We are making steam. Steam, we are running the turbine. Turbine, by running the turbine, we are making the electricity. There are so many energies. Chemical energy we are converting to heat energy. Heat energy we are converting to mechanical. Mechanical to electrical. So you can transform, but you cannot create and internal energy, the change in internal energy only will be measured, not the absolute value, because absolute value we do not know in case of the internal energy. So the first law of thermodynamics, simple in mathematical terms, delta E is equal to Q plus W. Q is nothing but heat, W is nothing but work, and delta E is internal change, work, internal change. Internal energy change is the delta E. Here plus minus and all these things, if work done by the system, it is negative. If work done on the system, it is positive. Similarly, sometimes only one can heat, by heat only you are changing internal energy, there is no work. Sometimes work is doing for increasing the internal energy, there is no heat change. But the general formula is delta E equal to, the delta E is nothing but change in internal energy equal to Q plus W. That is the first law of thermodynamics. We will see then further their applications and these things. Thank you.